Hello, everyone. Thanks for joining my session. Welcome to JCON this morning. Yeah, more and more companies and organizations worldwide want to collect more and more data all the time. In 2019, about 4 billion people used the internet. About 3 billion people were using smartphones. You know, they use it all the time and everywhere. And today, people around the world are working on products that were science fiction 30 years ago. For example, automotive, AI, machine learning, virtual reality, the Internet of Things. And almost every solution, every product works with software in the future. And software is eating the world. More and more things will be done virtually in the future. All of these systems produce tons of data or must consume tons of data. So modern software solutions must run in the cloud, must be able to handle tons of data, must be able to connect and query complex data structure in real time. And in order to do that, we need the best possible performance. And the question for me is, who will be the guys who develop such exciting things in the future? Which programming language will be used for that in the future? And many people ask me all the time, is Java ready for that? And what's coming up in Java in the future? Our databases of today are still fast enough for doing such kind of things. And in this keynote session, I like to talk a little bit about the future of Java. And I'd like to give you a short introduction to the new Java Cloud Native stack, the next generation high performance Java that's just blows you away with its incredible performance. Yeah, my name is Markus Kett. Hello. And I have been working on Java almost 20 years now. And together with my team, we have been working on several Java developer tools, such like Rapid Clips. And we have been working on the Rapid Clips Hibernate tools for almost 6 years now. And for about 7 years, we were working or have been working on MicroStream now. Yeah, let's jump into a slide. Here you can see the standard architecture stack of Java we have been used for almost 20 years now. And here we can see we have used the JVM, different JVMs, then with hotspot just-in-time compiler, with caches, Java Enterprise, and or Spring for building applications, and of course our business logic. And this architecture stack has worked for almost 20 years now, but it was built for monolithic applications. But the last years with Docker, the microservice architecture came up. And so we were forced to use this standard application stack also for building web services and microservices with Java and run this in the cloud, containerize this in the cloud. Yeah, and the question is this standard architecture stack suited for cloud native applications? And maybe we have some issues here. The JVM, we know that is not as fast as native apps are, of course. And the JVM startup time is not super fast. The memory footprint is sometimes very high. And then when we have a look at our architecture, then we see we have many layers, complex layers, heavy wide architecture, and all of these is built for monolithic applications. And then we have the database queries. And the question is, why are Java database applications often so slow? And all of these could be a problem when we want to develop Java Cloud Native applications, especially for the cloud. Yeah, because microservices actually should be small, should have a small memory footprint, should be deployable in containers and fast to serve requests, should have low startup times, and should be stateless and scalable. Then now, some years ago, MicroProfile came up. And what's MicroProfile? With MicroProfile, we can now write microservices for the cloud. And it's a kind of like Java Enterprise or Spring replacement, specially built for microservices and for the cloud, and replaces also the classic application service. And now we can build our microservices with a lightweight, kind of like Java Enterprise, specially built for containers, run Java apps in containers, and for microservices. And here's a small overview about the microservices frameworks. And now with these frameworks, we are much more flexible. They are
habe ich jetzt falsch umgestellt?
Markus, you're muted.
Does it work now?
Yes.
Okay, you have seen a lot of pretty slides. Okay, I continue here with the GraalVM, and this is really a game changer. So I talked a little bit about the new microservices frameworks, and they all support GraalVM. And GraalVM, of course, is an absolute game changer here for this architecture. And with GraalVM, now it's possible to write native images with Java. And it supports also other programming languages, but for most people here, Java will be most interesting, or JVM languages. And now we are able to write native apps with Java, which are as fast as C programs. And that's really incredible. So here we get native images, super fast startup time in milliseconds, low memory footprint. And this is really a dream for Java developers. The question is, what's about persistence? So we have now a super lightweight, kind of like Java Enterprise or Spring with the microservices frameworks. And we have with GraalVM a super fast Java, as fast as C. The question is, can we also accelerate our database queries in Java? Because in the past, the Java database applications often were very slow. And this is often a problem in many projects. Here we can see we still use JPA, we still use the caching frameworks for accelerating our database queries. And so we didn't change anything here in this case. And the big question is, what's the reason for that? Why are the database applications in Java often so slow? And why do we have to work on performance issues all the time? And here we can see that Java applications, or in Java, everything is an object. And when we process data in Java, then everything is an object. We are used to use objects and object graphs in the memory. But as soon as we want to store data, then maybe we are a little bit in trouble, because then we have to use database systems, and they work totally different. The databases store data in a totally different data structure. They use tables. We all know that. Actually, it's not possible from a technical perspective to store complex object graph in tables. So here's an impedance mismatch. And to solve this problem, we have this object relational mapping frameworks. The standard here is JPA, and the de facto standard framework here is Hibernate. So with Hibernate now it's possible to store objects in relational databases by mapping the object relational model to a table model. And what's the problem here? Here we have to convert the data behind the scenes. So Hibernate has to convert data behind the scenes, or has to generate objects. When we get the data back from a database, then we never get back objects. So we have to generate objects behind the scenes. And this is kind of like data conversion. And data conversion always is slow. It takes computing time, and object relational mapping takes lots of computing time. So, and then we have the queries are executed on remote machines. And so we have to send the data through the network. And this is the reason for this network latency we have. And the network latency, you know that is very expensive. And this increases the cost of our infrastructure. So it costs lots of performance and increases the cost of infrastructure, especially in the cloud. But it's standard. And the question is, are the NoSQL databases, are they better? And when we have a look at the data structure they use, then we see all the NoSQL databases use complete different data structure than the relational model, but they are also completely incompatible to Java object graphs. And this is the reason why we need a mapping here also. So we have the same problem here. We need a mapping, and this means we need data conversion. Data conversion takes lots of computing time and slows down our systems and increases the cost of infrastructure. Maybe in-memory computing can help us. Of course, when we have a look at the numbers, then we can see using memory or storing the data in memory is incredibly faster than access to a hard disk. And so this is the reason why in-memory computing is now a very important layer in our standard architecture. So here we can see a standard architecture of today using object relational mapping framework, uses a local cache, maybe a distributed cache. And so now we can accelerate our database queries. But the problem here is the complexity increases more and more. So now we can use maybe in-memory data grids, in-memory databases, local cache, distributed caches. Yeah, the complexity increases more and more. And the question is, when should we have access to memory, and when should we have access to a database? And in practice, we see that the applications mostly consume the data directly from in-memory layer. So reading data, the data we read come from in-memory technology, and the database is used for persisting the data only. So this is the most efficient way to accelerate a database application. Mostly, it depends on the use case, but mostly it's used as we can see here on this slide. But then when we have a look at caching, then we should expect that access directly to a cache should be super fast. But sometimes it is not. And the question is, why? The answer is, in a cache, we do not get back objects from the cache. So, and when we have more complex queries, then they are not hit the cache. So we have to access to the database again. And when we get the data back from the cache, then we also need object relational mapping to get objects back. And so we have here much latency, even when we have access directly to the cache. Yeah, and we can try to improve this again and again. And with my teams, we have worked on these issues for many years. And the problem is the core technology, the core problem is the object relational mapping. We cannot eliminate this problem. So we will have this problem in every project. The only thing we can do is to optimize our solutions to be a little bit faster. But the core question is really, can we do things different? So the answer in the cloud is you have performance issues. Don't worry, you are in the cloud, you can scale. And so, yeah, copy the machines. In practice, the problem is, of course, the costs will also scale. And yeah, this could be a problem in the future because the systems are growing rapidly. So we have to collect more and more data. We have seen in the video, but you can't hear anything. Sorry for that. But yeah, we have to scale and have to collect more and more data, to relate more and more data, and to query data in real time. And so this will be more and more expensive. And this is the reason, yeah, why these today's big data application infrastructures are so big and so expensive and difficult to develop and to maintain. And what's about the developers? So from a developer's perspective, we have also some disadvantages here. When we use classic database systems, doesn't matter which database you use or which data structure, you always have two data models. You have your Java classes and you have your database data model. And so if you change the data model at the database side, you have to adapt your classes. And in the other direction, the same problem. If you change your classes, then you have to adapt your database data model. Otherwise, you're in trouble. So we have we have to use these complex object relational frameworks. We have to use caching layers to accelerate our ORM frameworks. So sometimes you use additional distributed caches on top of that. So the complexity increases more and more. This is sometimes a problem for developers. Yeah. Then we have these heavy weight dependencies. Actually, we shouldn't have heavy weight dependencies in Java. So actually, we love POJOs. And it's very effortful for testing and deploying such architecture stacks. And now I'd like to introduce you to MicroStream, talking a little bit about what we have, what we are working on the last 6 years almost. And here is a short live demo. And yeah, normally in live demos, it doesn't work. So the same problem here. But maybe you can notice the link here and start the live demo in your browser. Then you can see the application running. And we have built a real world application to show what happens here. We have two different applications. One application is running based on a Java standard stack using Hibernate EH cache and the Oracle database. And the other application is running with MicroStream without any caching layer and with the Oracle database. And then we can see that all queries are executed up to 10, sometimes 100, often 1,000 times faster with MicroStream in comparison to a JPA query. And this is not a fake application. This is a real application. You can download this from GitHub and play around with this application. You can implement your own queries. And now the question is this a trick, or how does it work? Or is this only a marketing tool? Yeah, it is not. It's real. It's working in practice since 5 years now, and is now available for free for the Java community. And on top of that, I have a very cool present, but later more. The question now is, how does this work? And we believe Java provides actually everything you need to build ultra-fast database applications. We always talk about the database data structures and what data structure could be the best fit for us. But actually in Java, we have already a perfect data structure. It's an object graph. With an object graph, you have a data structure where you can build and you can process very complex data structure. Then you can build your object model freely and elegant object models. You can use single objects as well as collections, for instance. So you can use any Java type. So everything what Java provides, you can use this in your object graph. And the object graph, of course, is in memory. So it's managed by the JVM, and yeah, it's really high performance because yeah, it's core Java and fully managed by the JVM. And on top of that, you can query an object graph also. And Java provides you the perfect query language for that. Java Streams API, you know that. You can use Java Streams API for querying even huge and complex object graphs, maybe with lots of gigabytes in memory. And every single query will be executed in microseconds, not in milliseconds, in really microseconds. So sometimes it depends how you build your object graph. But even if you have a bad object design, then the Streams API is so fast that you get access time in microseconds. Then this is really super fast, and everything is core Java. So great. You can use it as an in-memory database and replacement for a cache, for a local cache. Okay, but what happens? Yeah, if we lose the machine, so if the power is off, then you have to store data. And with MicroStream now you get a storage engine for storing your object graph and loading your object graph dynamically. And with MicroStream, now you're able to store really single objects and subgraphs. You can use every Java type. You can store any Java type for that. If you have references in collections, then only the references, of course, are stored. Yeah, I show you here a super small demo. So now here we can see, now I have stored a subgraph, and every store is only one store method. This is super simple. You only need a storage manager, instance of a storage manager, and you need a persistence for that. You can choose a database system for that, and then MicroStream stores your subgraphs. So, and now the stored object is always stored appended to your storage. So it's a append strategy. And it's also transaction safe. and it's multi-threaded. So the more cores you have in your machine, the faster will MicroStream store your objects. And in the, here we can see it's really only one store method to store a single object, or in practice, mostly we will store subgraphs. And now in the other direction, you can also load single objects as well as single subgraphs. And then when we load the subgraph, then the loaded object is merged into your object graph automatically. So your object graph in memory gets updated automatically, so you don't have to deal with object copies. This is very convenient for Java developers. Yeah, and when the question, one of the most asked questions is how does this work initially? When you start the application, then the entire object graph is loaded, but only the object IDs. So this is very important. MicroStream loads all object IDs in the memory, and then you get a fully indexed object graph. It's kind of like fully indexed database. And then you load objects or object graphs lazy into your RAM, and it's merged into your object graph. So you can use lazy loading for that. And this is also multi-threaded, so the access, the entire I/O process is multi-threaded. And here we can see some code how lazy loading works. So, and here we can see an architecture about MicroStream. This means with MicroStream, we read the object graph from the memory and store the object graph and serialize the object graph into any database system. And for doing that, we have written from scratch completely fundamentally new serialization that is faster than the Java serialization. It's more secure, and it allows you to store single objects and subgraphs. And you can choose your storage solution. So you can use now a relational database for storing your object graphs, as well as NoSQL database, or you also can use a cloud object store or a distributed cache. And here we have connectors currently for all important Oracle solutions. So Oracle Relational database is supported, as well as Oracle NoSQL, Coherence, and the Oracle Cloud Blob Store, as well as MySQL, and also SQLite. And this is for mobile devices. So with MicroStream now you're able, if you have a Java application running on Oracle, then you can accelerate your Oracle database queries 1000x with MicroStream. And this is really incredible. With MicroStream, you got additional features, but the most important features are a class versioning. So one of the most asked questions is, what is when the classes are changed? Okay, then this is not the problem for MicroStream. You can change your classes. Then when you start your application again, in the object, the old object version is loaded from the storage. Then the engine compares the two versions of the object, and it's solved by MicroStream automatically behind the scenes. So primitive types can be managed by the engine, and if you have more complex objects, then you can define a custom mapping for that. So yeah, and then we have from time to time more and more legacy objects in our storage. So the storage is growing and growing because of this legacy objects stored in the persistence. And for that, we have kind of like garbage collector working on a file base. So you can define how the garbage collector works, and the garbage collector removes the legacy objects from your storage. And so this is very easy to use also. And then we have a lot of tools. We have a user interface for that you are able to have a look on your stored data. Then we can have access from with the REST API, and you also can use GraphQL for allowing third-party tools accessing your Java application. So everything here is what is important is supported, and we also work on a strategy for SQL dialect for querying the storage data with the SQL dialect. Yeah, and MicroStream is very easy to use because it's a tiny Java library with no dependencies. So you can include it with Maven in any Java project very easily. Use it and run your applications with that. And then let's have a look at our microservice architecture of today. Here with object relational framework and a local cache, and then with MicroStream you get the tiny microservice, super tiny and very easy to use, super lightweight, no dependencies. When you use MicroStream, then you don't have to use annotations or implementing interface or something like that. The only dependency is really to the JDK. And then with MicroStream, your architecture looks like this. Yeah, and it replaces JPA and Hibernate or Hibernate together with a local cache. And then let's have a look at the entire package now. Now we have the GraalVM or Quarkus you use, for example, for building your native images. Then you have what you get out is a super fast Java application, as fast as C. Low memory footprint, incredible fast startup time. And then with these new microservice frameworks like Helidon, Micronaut, Spring Boot, etc., you get a lightweight kind of like Java Enterprise. And then together with MicroStream, you get the ultra fast, tiny persistence for building the fastest Java apps on the planet. And this works also on mobile devices. I don't know if anybody works here with Android, then you can use MicroStream on Android devices as well, building mobile apps or edge applications. So from core to edge, everything is supported. And a lot of people ask me again and again, what can we do with performance? So I don't know. Maybe you have some ideas. But I think we can build now applications which were not possible in the past. So we can build things that were science fiction 30 years ago. With performance, you can develop revolutionary new features and innovations and new products. And this is really built for cloud native, and it's perfect for AI, machine learning, and all these use cases for the future. And another reason is why to use MicroStream. If you're not so innovative, then you can maybe save costs. Because of this performance now, you're able to minimize your cost of infrastructure. At the reference customer at Allianz, the insurance company, we have an application. Actually, we had to run this on a huge common cluster, and costs them more than $100,000 per year cost of infrastructure. And now this application today is running on only one single machine. It's incredible, and we save aliens up to 90% cost of infrastructure with this performance. And together with GraalVM, Quarkus, and MicroStream and this new microservices frameworks, you will save lots of cost of infrastructure. And the best thing for developers is that the programming model is very convenient. You only have one data structure, your Java classes. You only have one data model. Then no more mapping, no more JPA, no caching framework needed. Super easy query language with Java Streams API, completely type safe, no dependencies. You can write pochos. That's it. Super easy to use. Core Java only. Yeah, this dream for developers. No more selects. You only have to call getter methods, get methods to load your objects, and it runs almost everywhere where Java runs, on a desktop, on-premise hardware, on the cloud, in container. Built for microservices. You can run it embedded with GraalVM native. The only requirement is Java 8, and you also can use it with all JVM languages, of course. You can build apps from core to edge, as I mentioned, and you also can use the MicroStream serialization for storing objects and loading objects into Kafka, or loading objects from Kafka. You can use MicroStream as a standard serialization, if you like. And if anything is missing, then have a look at the amazing Java ecosystem. You'll find solutions like Lucene for querying data, GraphQL for allowing third-party applications get access to your storage. Everything is here in the Java community, in the ecosystem. That's great. The release cycle is adapted to the Java release cycle. Every 6 months, a new release is provided for free. So MicroStream is completely free for commercial use. And only one note, you have to be a Java developer. So unfortunately, SQL gurus are out of the game, but it's especially developed for Java and for Java developers. And now, the best thing I can announce now is MicroStream is going open source. So we have decided to open source this. Currently it is free already, but yeah, as I mentioned, we have decided that we open source MicroStream and contribute it to the Java community, so can use it, combine it with all these fantastic frameworks. And we like to introduce a hackathon. So if you want to join our MicroStream workshop on Friday, then you will learn everything about MicroStream, can ask questions for 4 hours, can do a live coding with us, together with us, with our CTO, Florian, and we will talk about how the hackathon works, how you can join the hackathon. Yeah, use MicroStream, build any exciting use case with MicroStream, show how it integrates with frameworks, with for instance, Helidon, MicroProfile, Quarkus, GraalVM, and so on, and yeah, win $10,000 until end of November. Yeah, and now, do we have some minutes left for questions?
Then I will just talk into the microphone.
Great.
Thank you for the presentation at first. And my question, the requirement having Java 8, does it mean only Java 8 or also Java 8 and above, for example, Java 11?
Yeah, of course, above.
Okay, perfect.
It's the minimum.
Thank you.
You're welcome. Thank you for joining. Thank you for your time. Bye-bye. See you.